So today we're going to go over the normal distribution. Last lesson we discussed how the normal distribution can be linked to a range of data which forms a bell curve as follows. Normally, excuse the pun, we're going to feel stoked about this. This is the normal curve distribution. What I'd like you to do is spend approximately 4 minutes copying all of this down. What I'd like you to copy down is the diagram and the title above it. You may copy the text below it down as well. However, I'm going to explain this to you and hopefully it will make more sense. The middle line of the normal distribution curve represents the mean. And then the axis at the bottom represents jumps in standard deviations. So for every single normal curve, if we go from the central mean line and we go to the number 1, this represents a jump of 1 standard deviation. If we go to the number 2, this represents a jump of 2 standard deviations. And this means the data that is above the mean. Similarly, you can jump from the mean to the left. So this would represent a jump which is 1 below the standard deviation. Now you're probably thinking, well, what does standard deviation even mean? Standard deviation is calculated using quite a complex formula, and we have done this on the TI-84 calculator with a more simplistic formula. If we have a set of data and the data has very little correlation, like this, then the standard deviation number, or SD for short, is going to be very large. This is because the standard deviation represents, on average, how far away are each of the points from the mean value. And because there's such a large variation, the standard deviation is very large. Whereas if you have points which more or less follow some sort of correlation, and they've got a positive strong correlation or a negative strong correlation, the standard deviation is going to be small. And the reason why is because there's not much variance between these values. So I'd like you now to pause this video and I'd like you to copy this down. You need to make sure you include the numbers at the bottom, the title, and also these differing percentages. So these percentages mean how much of the data occurs. So if we're going to go from the mean to 1 standard deviation above, you can see that 19.1% of the data occurs half a standard deviation above, and 15% of the data occurs between 1/2 to 1 standard deviation above. This means that most of the data is going to be closer to the mean. This is why you have this bell curve shape where it rises up in the middle, because most of the data occurs in the middle section of the graph. Therefore, we're going to say that approximately 34% of the data, which is these two added together, occurs between 0 and 1 standard deviation above the mean. So please pause the video and copy down everything in this red box, and you may want to make some additional notes, which I've done in the pink and the red. Off you go. Welcome back. So now we're going to go into some actual questions. Now in the exam there are 2 ways of doing this. You can either memorise all these numbers within the graph and memorise the numbers below, or you can do it on your calculator. We're going to do it through the memorisation route first. What percentage of the population lie where? So we're going to say 68% lie plus or minus 1 standard deviation either side of the mean. This is because we're going to include everything in this pink section. And if you add together these 4 percentages, you can see that these add up to 68%. Now, if we go on to the second part of the question, we're going to say 95% lie 2 plus or minus standard deviations above. So we're going to return to the mean. We're going to go 2 standard deviations above, which takes us to this point, and then we're going to continue the pattern, and this time we're going to study all the percentages which are in the spiky box. If we added together all of the red percentages, we could see that 95% of the data occur here. And then finally, if we wanted to do plus or minus 3 standard deviations, it's good to remember that 99% is your answer, because there should be another small percentage here, and then at number 3 and at minus 3. You will see that there's only a small tiny bit beyond the 3 and the minus 3, which means most of the data occurs 3 standard deviations above, 3 standard deviations below. I'm stoked yet again. So let's go on to some actual application questions rather than just reading the graph. So let's say we have got, I'm sorry, I'm not quite sure why this stoked skateboard keeps appearing across the screen. Let's say we have the mean of a person is 170 centimetres. Well, for this particular graph, perhaps we could use 170 centimetres. However, the mean doesn't always refer to a positive number. But let's say we're going to go for height in this instance. Let's say the mean is 170 and the standard deviation is 15. So if it's 15, one step from 0, which is the middle part of the graph, to 1 standard deviation, this is going to represent 185, because we need to add 15. If we go from 1 to 2, we need to add another 15. So that's going to give us 200. If we go from 170 to minus 1, that's going to represent 155. 155 to minus 2, that's going to represent 140. So if we study this, we can see, by focusing on the central part of the graph, like we did on the previous slide, that 68% of people, based on this information given in here, are going to be between the lower bound and the upper bound, which is going to be 155, and let's call the height of the people x, and the upper bound is 185. So this effectively is how we use this graph in practice. Hopefully this is starting to make a lot more sense now. So let's go on to 2 questions. What is the probability that a random chosen person would be 2 standard deviations below the mean? So if we're going to go for 2 below the mean, we're going to select all of the numbers I'm going to tick. This is up to 2, 4.4, 9.2, 15, 19.1. We would just add them all together. Now for question 2, we're going to change colour for this one, and it says we want to go 1 standard deviation above the mean. So let's have a look at that. 1 standard deviation above the mean is going to be all of the pink ticks. So we need to add these 2 pinks together. So answer for number 1 is going to be all the reds added together, which is 47.5, and answer number 2 is adding together these 2 pink, which will be 34%. Nice and easy. If you didn't understand that, please speak to your partner, or please pause the video and think a little bit more further. So this is your turn now. These are your questions. A person lies between 3 standard deviations below and 1 above. I'm going to give you a hint for the first one. 3 below Well, we know that 3 above and below is going to be 99%. So 3 below, so the first part of the question, is going to be half of 99%. So quick maths, we're going to say that is equal to 49.5. And then you have to use the diagram and work out, well, what is 1 above? Once you've worked out what 1 above is, you are going to add 49.5% to the 1 above value and then have a go at these other two values. I would like you to have a go at these questions now, and hopefully you're going to be happy you understand what you're doing. So please pause the video. Welcome back. Hopefully you would have got the following answers. So for the first question, we are going to have 49.5% as discussed, and 1 above is going to be an additional 34 because you would add these two black numbers together. So 34 plus 49.5 is going to be 83.5%. A person lies between 1 below and 2 above. So this time I'm going to focus on 1 below, which is this value, and 2 above, which is going to be this value, and everything in between. So we're going to cumulatively add all of these together. So we're going to have 68, which is going to be this line, plus an additional 9.2 and 4.4. So that's going to be 68 plus 13.6, which is going to be 81.6, I believe. If you disagree, please let me know. A person lies 3 above or more. So this one's a little bit more tricky because we want to have a think about if it's 3 above, it's going to be at this point of the diagram. It's going to be a very, very small percentage, and as we said, most of the diagram between -3 to 3 covers 99%. These little bits on the end are only going to represent 0.5%. Now this is a lot of things to remember, particularly with the diagrams. So next we're going to show you how to do it on the calculator. Before we move on, I'd like you to just add a couple of things to your diagram. We are going to talk about mu. We talked about this last lesson. Mu is the mean, and this is going to be the central line. So just add a mu to your diagram, and this is going to be called the standard deviation. So the space from 0 to 1 is going to be represented by 1 standard deviation. So pause the video and add this to your diagram now. So this is what we're aiming to get on our calculator in a moment. And I'm going to show you exactly how this works. So let's see if we can get out this screen. We want to find normal CDF, and this is a very similar way of finding the binomial page as well. So opening up my calculator, we're going to go on to vars, I believe, but before I press that I need to make sure I quit. So on the vars button you need to press the distribution which is above, so press the second and then the vars. We want to select number 2, which is normal CDF, and as in the binomial, this is because we want to add things together. Press enter, and now this is the screen you should get up. Please pause the video and make sure you can see a screen such as the following. This will represent the lower bound, the upper bound, the mean, and the standard deviation. Let's look at this in practice. So let's have a look. If mu is 10, let's change that to 10. Before it allows us to change mu, and standard deviation, we need to alter the lower and the upper bounds. So the question is, find the probability that someone is less than 12. Now, this could represent any set of data, not just height. So if someone's height is less than 12 or something is less than 12, the lower bound is going to be negative infinity. And the way you do that is you write a really small number, or you can use the standard deviation part of your calculator and replace this with an E. We did this in D1. Now going to the upper bound, we want it to be less than 12. So we need to put the upper bound, the maximum number it can be is 12. We're going to say, therefore, our mu is going to be 10, as this is given to us in the question, and we are going to say that the standard deviation is 2. The question would be something like this, and you would have to be able to translate this question into this on your calculator, or you could use the graph. Let's just talk about how this works on the graph as well, because this will probably make a little bit more sense to you. If we take the graph, and I'm going to annotate it a little bit now so you can understand. If we look at the graph here, we're going to say that the mu this time is going to be 12 or 10. We're going to say each of the standard deviations are 2. So to get from here to here, this would give us 12. This would give us 8, etc. This would give us 6. So this is going to be going up in 2s. We're going to say we want the probability that someone chosen is less than 12. So basically, we need to select everything in this part of the diagram. We know that the smallest value could be really, really small, and it doesn't necessarily need to be positive. So this is why we have to select a lower bound which is really, really small, because this doesn't necessarily just refer to positive numbers. We know the upper bound is 12, which is why we put the upper bound. We know that mu, or the mean, is 10, and we know that the jumps in the standard deviation is 2. Excellent. So let's go back to the calculator. Going back to the calculator here, what we're going to do is we're going to press enter and we're going to press paste. And that is our lovely answer, 0.539, which means the probability of picking someone who is less than 12 is going to be 53.9827%. What I'd like you to do now is, using that information either on the calculator or using the diagram, I'd like you to work out for each of these questions. We've got 1, 2, 3, 4, 5, 6 questions. So this should take you at least 12, if not 20 minutes to finish, and pause the video. Welcome back. Hopefully you got these answers. If you did not, go back and check the ones you weren't that sure on.